Hi, and welcome to a screencast on extracting data from two different types of sources. We're going to extract data from a JSON API, specifically a API that's been written as a RESTful API, and we're going to use the Star Wars API for this. And I'm going to show how you can extract data from this using Ruby, and then you can get that data and put it into a seed script to populate models. And then after that, we're going to use some screen scraping or some web scraping techniques to get data off of a particular web page that doesn't have an API. So we're going to visit or have a script to visit the Red River College Business Information Technology course page and extract the information within this page. But we'll start with the Star Wars API. So this is an API that has a variety of endpoints. It has a people endpoint, it has a homeworld endpoint, it has a films endpoint, and a few others. And you can see here within the browser documentation, you can put in an endpoint and you can see the results that are coming out. So for people/1, we get Luke Skywalker. If I change the identifier and make a new request here, you see that that's C3PO. We can also go to films number 1, for example, or planets, some number, right? It doesn't have to be 1, we could try 4. And so what I'd like to do is write a quick program that will scrape the first few people from the API. It'll just go from ID 1, maybe up to ID 10, and print out some information about those people, like their name, their homeworld, the films that they were in, and this will involve visiting a few different endpoints to gather this data. So we're going to start. Now, for your projects, you would be doing this within the context of a seed script. I'm just doing it within the context just of a regular Ruby program, but it's going to be basically the same what you would need to do. I'm not going to end up adding any information to models. I'm just going to display the information to the screen. So what I want to start with is I'm going to require in a library that's part of the Ruby standard library called OpenURI. And what this does is it allows for Ruby's file open command to also support opening up URLs to read sort of either the HTML from a URL or, in our case, the JSON from a URL. And just for testing purposes, I'm just going to do a very quick little test to see if I can open up a URL and output its contents. So I'm going to say puts open. The URL is going to go within there, and then I'm going to read the content immediately and have that putsed out. And what I want to do is I want to specifically go to this endpoint right here. So it starts with that. And then I'll have it go to people/1. And we should see some information about Luke Skywalker if we run this. So I'm going to clear my screen here, and I'm going to run Ruby Star Wars. And there we are. So hitting an API endpoint and reading back its JSON contents is not that difficult in Ruby, right? As long as we've required in the OpenURI, we can just use the open command, pass it a URL of an endpoint, and read that data. What I'm going to do next is I'm going to make a little helper function that we will be able to use throughout our code here. Oh, I've got 2 OpenURIs in there. Okay, and so that was a test. So what I'm going to do is I'm going to define a function that will visit the Star Wars API for me, and it will fetch a particular URL. And anytime we fetch a URL, it's going to come as JSON data. We want to be able to use that data within the Ruby program, so I need to parse that. And that's why I also required in this JSON library here. This is going to give me the ability to take in JSON as text and parse it into a Ruby data structure. So I want to call json.parse on the URL being read. So in this case, we'll take the URL in, we'll feed that to the open command, we'll read the result, and all of that will be passed to the JSON parse method. Now, I'm making the assumption here that that every request is going to work. I'm not doing anything special here around catching errors, error handling, exception handling. You may have to do that if you're working with an API. Maybe that's a little flaky, or a network connection that's a little flaky, but I'm just assuming that everything is going to work. So that's just my little test here. And what that means is with this, I should be able to, let's say, get some information about Luke Skywalker by going to that API. And again, the URL, I deleted it, I will go get it again. Specifically that people/1. And then if we look at the API documentation, we should be able to see that if we go to the people endpoint and request that, we should be able to get back a name from the person that is returned to us. So I should be able to put out name. So let's try running this script here. Ruby Star Wars RB hits my endpoint, and there's the name coming out right there. Okay. I'm going to be fetching a number of people, and so I'm going to make another little helper function here, and I'll call it person URL, and it's going to take in an ID. I want it to build a URL that looks like this. So cut. I'll cut that from there, like so, and I'll paste it. Oops. Paste it in here, and all I want to do is append. I'll make this a double quoted string here, and then I can use interpolation inside of it. So that should build a person URL to hit the people endpoint for a particular ID. And so I could now use that again to fetch the same person data for Luke Skywalker just by going to person URL and 1. And then again, it should print out Luke Skywalker when I request the name of the data that came back. So let's try that out. Still working. Okay, so I'll just put a few little comments here. This will fetch and decode JSON resources from the Star Wars API by URL. And this one will build the person by ID people endpoint URL. And now we can get to work. So let's do just that. I'm going to start by defining that I want some character IDs. These are going to be these identifiers right here. And I'm going to start off just for debugging purposes, just with a range of like the first 3 characters, and we can bump that up later on when we want to fetch more. And then I can go to those character IDs, and then for each one I can grab the character ID. And so in this loop, that character ID will first pass to the loop be the number 1, second pass to the loop be the number 2, third pass to the loop be the number 3. And I can fetch the person by going to the fetch, and I can use my person URL, and I can use my character ID. So I'm using both of my little helpers here. I'm taking the character ID right here, I'm passing it into the person URL helper. That generates the URL I need, which I then hand off to Star Wars API fetch, and that will return a decoded JSON structure as a Ruby data structure called person. That's great. And down below here, I'd like to be able to put out that person's name. And so I will do just that. name, person, position name. And I can put when they were born, because that's in the data set as well. Person, and I looked at the data set earlier, and it was birth year, which is where that data was kept. And I should now be able to run this code and visit the first 3 people in the character API or the people API by ID, person ID 1, 2, and 3, and print out their name and birth year. And let's put some blank spaces between each character with some /n's. And there we see Luke Skywalker, C-3PO, and R2-D2. Great. One of the things about the API we're working on is that it is a RESTful API, and often in RESTful APIs, the data that comes back to you will include other endpoints that have more data for you to gather. So for example, if we wanted to print out which homeworld each of these characters were from and the films that they were part of, we'd have to visit other API endpoints. If we go back to the explanation here, you can see that when we request a person, some of the information that comes back to us is the homeworld, and that leads to a particular endpoint for the planet's endpoint, and also an array of films, and that leads to a variety of films that this character was in. So let's start with the homeworld. So in order to get the homeworld name, our script is going to have to follow the person's homeworld URL, and then if we try that out here, planet/1, we're going to get the name of that planet. So let's do that in code. Right here, we're going to say the person's homeworld. We got to go to the API, and we're going to go to the person that we just gathered up. And we saw from the API docs that their planet URL is stored at position homeworld. So we're going to make our second API request right here. Once that's done, we should be able to put out the homeworld at position name, like so. And again, I'm going to run my code. Oh, I've got a syntax error, and that will just be because I forgot a curly brace. There we are. Skywalker, Tatooine, C-3PO, Tatooine, and R2-D2, Naboo. If we look at the information that's provided with a planet, you can see that there's other information, including population. And so that's what I'm going to include some population details as well. And so for that, I'm going to put it on the same line here. I'm going to say that the homeworld is, and then put out the homeworld name, but that it has a population of, and then I will go to the homeworld at position population. And I close the parentheses. Running my script again. Great. And then the last thing I want to do is I want to fetch all of the films that this character, for each of the characters that they belong to, and grab the names of those films. And so you can see that for any given person, if we go to their data's films property, we'll get an array of film endpoints to visit. So that's handy. So I can say films equals, and so it's person at position films is where all those URLs are. Person at position films is an array of film endpoints. I'm going to map over each one of them, meaning I'm going to visit each one in turn, and I'm going to grab the film URL from each one, and I'm going to use my API to fetch that URL. And the way that map works is it's going to return an array of the same size as this one, but populated with what returns from my fetch of my API. And so if this person had 4 film URLs, I'm going to get an array of the results of 4 film endpoints. So far that's probably the most complicated part here. This could have also been performed by using like an each loop or something along those effect lines, but I just felt that it would be good to sort of show the use of, of map here. So again, we're mapping over the URLs and we're returning a URL of those results of visiting those URLs with our helper fetch. So that's going to give us the films. What I need to do next with those films is display them in some way. And so I'm going to write a little helper method to do so. Because the data from those endpoints, let's see what it looks like. If I go to film/2, for example, I really only need to grab the title of the film. And so I'm going to make a little helper method that will build a nice little list, format an unordered list of films from films endpoint data. Film title list of film titles. It's going to take in films. Okay, so let's see, film titles is going to be films. So I'm being passed an array of endpoints here, or endpoint data. So I'm going to get an array of hashes, and each hash is going to have a title. And so I'm going to use map again just to grab all the titles. I'm going to say map, grab each film, and then give me back its title. So film titles here is now just an array of all of the film title strings. So I've effectively stripped out all the rest of the data. I guess for now I can just say film titles join. Initially I'll make it a comma delimited list, and then we'll work on making it like an unordered list. But comma delimited list is simple. I can just join the array using comma space as glue. And so here I can put out films, and I can use my film title list on the films data that I have. And there you go. You can see Luke Skywalker, the films that they were part of, C-3PO, R2-D2, all those cases. Okay, yeah, maybe we'll just format the output a little bit better, and we'll go from there. And so what I'm going to do is I'm going to line some things up just so that the output looks a little bit more structured. Run that again. And then I'm going to have to build that list quickly. So there's the structured data. I'm going to make the, I've got some text I could paste in here for making the name look a little bit fancier. A little bit of ASCII art for the name. Take the actual word name away. And I'm going to call ljustify to add some extra padding so that the beginning and ending of this sort of fancy text here will always sort of be the same for short and long names. I run this again. There we get sort of our fancy little scroll. You can see the names always start at the same position, and because the padding that I put in with the ljustify, that sort of end trail sort of ends at the same position. And now I just need to sort of better format this to be a nice delimited list, maybe instead of a comma delimited list, I can make it be dashes. So I could start with a initial dash, and then instead of joining on a comma, I can join on a new line, and then I want it to have how many spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's try 11 spaces. Dash. Save that up, and we'll try that out. And there we are. That looks pretty good. Maybe I'll separate the person slightly out from there. So a few extra spaces after the name. And now we can maybe try 10 characters. And there we are. Our characters are coming out. You could imagine at this point, instead of actually writing the text out to the terminal, that you were capturing this information and putting it into different tables. Maybe you have a planets table and a films table and a people table, and you're putting all of that extracted information there. But that's it for my demo. It's a very quick look at how to build a API scraper that not only visits a collection of endpoints, in our case by ID, but then uses the data returned to find further endpoints. So from the data that we received from the person endpoint, we were able to find the homeworld endpoint, which led us to the planets. And then that gave us a particular homeworld. And then also from the person data, we were able to go and find a collection of film endpoints, map over each one of those, visiting the API for each one, and then outputting all that information down below. So that's a quick example of how to build a JSON RESTful scraper. And then the next thing I want to build is, like, what if you want data that is not behind an API but is up on the web, something that you can get from a web page but is not accessible by way of an API. For this, we use what's called web scraping. So what I'd like to do is I would like to have a program that visits this URL, which is on the Red River College catalog site, and I'm going to have it specifically visit the Business Information Technology page, and I would like it to find the course code and the course name for all of the courses in the program, and then for each one of them, I would like it to grab the description, the course description for that course. Okay, so let's start with the code. This one I needed more than just sort of plain old Ruby. I needed to include another gem, So I have a gem file, and I've added to it the Nokogiri gem. If you're working in the context of a seed script in Rails, you don't need to add this because Nokogiri is already part of all Rails applications. So you won't even have to change your gem file at all. In your seed script, you also will not need these 3 lines. This is done for you automatically. As long as you run your seed script by way of Rails DB seed, Nokogiri and the rest of the Rails environment will be there for you. You will need to add this require open URI, and again, that's to allow the open command to accept URLs. Okay, so what do we want to do here? Well, we're going to go to the Red River College catalog URL. I have that over here. And specifically, the bit URL is going to be that RC catalog URL plus this stuff right here, right up to there. I'm not taking that because that was part of a link that I had followed. So just this part. And I'm going to save the HTML that's at that page by opening up the RC bit URL and reading it. And just to make sure things are working, I'm just going to put out what we get back from that. So this script should just visit that URL, read in the HTML, and print out the HTML for us to see. So clear this out and run Ruby on my RC bit scraper. And there it is. There's the HTML of that page. Well, what do we need to do next? I need the code to visit each one of these sort of look like table rows. You need to visit sort of each row and grab the course code, and then from the link, the name of the course. And I want to do that for all of these courses. So anytime we're scraping from the web, we're going to open up the dev tools in our browser. That's, for me, it's Control-Shift-I. I'm going to poke around a little bit. So just seeing where we are. So this is a single row right here. You can see it's a div. That's the div that contains both the course code and the course name. And itself is contained inside of this div right here. This div that has a class of catalog course list. So, okay, that seems like a place to start. So a div with a class of catalog course list, that seems to be all of the courses. So if I scroll down here, yeah, scroll all the way down to the bottom. So that catalog course list includes all the courses. And then for each course, it looks like they're inside of a div that has a class of card body, and then further another class that contains more stuff. Okay, so look at that. So we have inside of a div of, here, what I'll do, trying to just keep track of this. I'll keep track of it over here, just in a comment. So I have a div where the catalog course list, catalog course list is what I'm looking for. And then further inside of that, we have this card body div with a class of card body. So I'm building up a CSS selector is what I'm trying to do here. Sorry, I didn't mention that before. I'm trying to build up a CSS selector that will target the information that I want to find. And then inside of that class of card body, it looks like there's a div and then another div inside of it. There's two divs there. They don't have really all that descriptive classes in it, but basically from card body, I want to go to its first child and then its first child again. Okay, so like immediate descendant and then immediate descendant. Yeah, okay. So when you want immediate like child relationship within CSS, we can say like that. And then there was I wanted another immediate descendant, but I wanted only the first child because we're going to go from card body, first level immediate descendant, second level immediate descendant, and there's two divs in here. I only want the first one because that's where the span and the A live that have my other information. And so I can use a first child selector. So this is going to find all elements that are nested from here and then further here, and then find an immediate child, which is a div, and then find another immediate child, and the first of those is where my information lies. So that's the hardest part about web scraping, is figuring this kind of stuff out. You can have the browser sometimes simplify this for you. So I could, sometimes what I can do is I can right click and you can go to copy, and you can copy like CSS Selector, CSS Path, or the library we're going to be using also allows for searching through by way of XPath. So let's see what those give us if they're any bit close to what we built up ourselves. So if we say selector, sort of, it's like a little bit more specific than I was finding. It's like find a div with a class of part or pt1 and then go to its third child and then immediate child after that, find the first, and the immediate child after that, find the first. Okay, that's sort of the computer generated way of getting to where we wanted to go. And what would be if we asked for the CSS path? Is that going to be better? And that's a very, very verbose way of getting there. So it's sort of from the body down, drilling down, overly specific way of getting to just that one thing. So that's not what we want at all. This one I don't quite trust. I like the one that I built up myself. This one would likely work, but it might be too specific. Like it might only get us to this very first one, whereas the one that I built up will give us the collection of all of these. Because if we look, the next one, or even further down this math bit right here, it too is inside of the overarching catalog course list, but then further it's also inside of a div with a class of card body, and then we go to its first child inside of it, and then the first child inside of that gets us to where we want to go. So hopefully the selector that I built up is generic enough to not just get us this very first one, but to get us all of them. So let's give that a test. Let's try that. Let's try that out using that particular thing. So we're going to try that out. We're going to make use of the Nokogiri library. To do this, Nokogiri is a XML parsing library that also supports HTML and allows for searching by way of CSS selectors or XPath selectors. We're going to use CSS selectors. So we're going to create a Nokogiri document. Nokogiri, specifically an HTML document, and we're going to feed in the bit HTML that we had printed out before. And then we're going to make a courses selector. This is the CSS selector that we developed below. Just turn that into a string. That looks good. And then we're going to try to find all the courses in the page by going to the RRC bit document that we built up right here and just saying by CSS, use this selector and see if you can find our courses. And we'll just put out courses dot see if size is a thing. This is going to be a Nokogiri object that comes back to us, so it might not have a size property, but we'll see what it does have. Okay, so try running this. $39 sounds about right for the number of courses. We could always verify this by counting them all, but it sounds like a bit of a right number. Let's assume that that is going to work. We can now loop over those courses. Each new course. And what are we looping over here? Well, we're looping over the collection of elements that were found. So what Nokogiri has done is it's given us a collection of elements where each element is like this div, and then this div, and then this div. And what we saw is for each of those divs, they contain within them a span, and the span is where the course code lives, it's the content of the course code, and a link, and the link text is the name of the course. So we've sort of targeted by CSS to get a bunch of elements, each one of them is a div, and then we want to extract from within them the contents of the span and the contents of the link text within there. So we could say course code, and the neat thing about Nokogiri is we could start with an element that we already found and do a further CSS selector within there. And there's two ways of doing the CSS selector. Just .css will find like everything that matches a particular selector, or you could say @CSS, which will find like the first thing that matches that selector. So I want to find the first span. There only is one, but I'm going to find it. And then I want its content. And then I'm going to put out the course code. If this works, I should see all of the bit course codes. And there they are. The first one being accounting 1070. Is that the first one up here? Accounting 1070, and the next one is ADEV 1008. ADEV 1008. So that worked. So I targeted all the courses, found those elements, and then further drilled down from the course element to its span. The other thing I saw is that inside of each of the course elements is a link, and that link has as its link text the name of the course. So let's grab that information as well. I'll find the link. That's going to the course element. This is better named course elements. I think Nokogiri calls them nodes, but I'm going to call them elements. Then I'm going to say course element. Course element, and then I'm going to do another @CSS to find the A. Then I want two things from the link. I want the course name from the link, which is going to be the link's content. And then I want the URL of the link, because I want to actually visit that URL to find the course description. So I'll say link href. And then I'm going to go to the link. I'm going to ask for the attribute by the name of href, just like all links have. And I'm going to get its content. And then so I should be able to put out the course code and the course name. And then immediately after that, the link href href. I just need that all on its own. And then puts to break it out. Let's try running that. Oh, what do we got here? Course name. I forgot an equal sign there. That's an easy fix. Okay, that's pretty good. We've got the course codes and their names. The URL isn't as helpful as I wanted it to be. It's like a relative path URL, starting with a dot, and it just links within the page. I wanted to show what would happen if we navigated to another page, similar to how we did with the Star Wars API. I know there is specific pages. Let me see how they look. So for programming 1, it has this more information. Course and description, and then it's the course code. So I could probably just build this URL myself. Oh, I see. That's interesting. When I navigate it on the page, it's at page fragment course code. If I was just to change that hash mark in the URL with a slash, I would go to its actual page, wouldn't I? Yes. So is that the same for all of these things? If I go to programming 3, that takes me somewhere on this existing page down below by fragment, and if I change that hash mark, that takes me to a completely different page, and I want to scrape out that content or the description there. Okay, so the URL that's coming back to me, I have to get rid of this dot, and I have to replace the hash mark with a slash. Then I have to put the proper full URL at the front of it, but I think I have that full URL up here. So I should be able to do that. Let's do it one at a time. So first, to get rid of this first dot, we can treat strings like they are arrays, and I can ask for like everything from, instead of like everything from 0 to the end, you can use negative indexes in Rails to represent the very last element of an array. So here I would be asking for like everything from the beginning to the end of the string. I want to just start at the first dot. So that's the way of like chopping off the first character. Let's make sure that works. I'll run my script here. That dot went away. And then I want to replace this down here, this hash mark. So I will do that with a global substitution where I look for that and replace it with a /. That looks good. So what that means is I should now be able to visit the page for each one of these courses and pull out their descriptions. So let's add a few comments while we go. So loop over all the bit courses divs located by the CSS selector. Extract the course code, course name, and the URL of the course page. Anytime you're building up a scraper like this, it's very, very sensitive to changes in the website. So if this, the structure of this link changed, even in a small way, my little sort of hack here would probably break. So it's a lot better to work with APIs if you can do it. But if you have to resort to web scraping, you got to know that you're building up something that's fairly brittle. Clean up the link by removing the leading period and replacing hash mark with a slash. And then visit each of the course, visit course page to extract the course description. That's what I want to do next. So I'm going to get the course page HTML. So I'm going to go to my open command, and I'm going to use this link href. But remember, it's just a relative path, so I have to glue on the RC catalog URL to the front of it. So I'll do that inside of a double quoted string, like this. So we'll go to the RC catalog URL slash the link href, which I grabbed here, one of these things. And then I will read that page. So that'll give me the HTML of the page. Now I'm going to have to make another Nokogiri document. Nokogiri HTML based on the course page HTML. And then I need another selector, because I need to find the description. So here's an example of one of those pages. I'm going to have to check to make sure that the selector works on each of the pages. That's sometimes a pain that, if the pages weren't machine generated, you might find differences between all of the course pages. Again, I'm going to use my inspector to sort of drill down here and see if I can find something. What do we got? What do we got? So it looks like the description and the prereqs are all inside of a div with an ID of body content course info. And then I want a child div within there. There's two child divs within there. I just want the first one. Okay. So ID of body content course info. So I need to make a selector is what I need to do. Course description selector, and I want a div. So again, we're building a CSS selector, so that hash mark means ID of body, what was it? Body content course info. Body content course info. And then I want a child div of that. Notice the Red River College page is not standardized around how it deals with CSS. Sometimes it's using dashes, sometimes it's using underscores. That's something you'll start to notice if you poke around and do some web scraping. You can see if there's a rhyme or reason to how people are styling things within a large organization. And for websites that have been sort of active for a real long time and lots of people have sort of built them, there may not be as many standards in place. So that course selector is good. That's going to let us target the course description div by going to the course page Nokogiri document, and I'm going to use @CSS again. And again, this time it's going to be helpful for me because I just want the first div that matches. My CSS selector is actually going to match both this div and this one here because they are both direct children of the div that has an ID of body content course info. I just want the first. So CSS @ and use my course description selector. Okay. And then I just want the content. And that means I should be able to print out, I don't need to print out the link anymore. I can just print out the course I'll leave that as the div, and here I'll go to course description div content. just give me the content of it. And then on this last one, I'll put a few more spaces, new blank lines between each course. So let's see if that works. It worked for a little bit. Financial accounting, programming 1, and then on math for bit, undefined method content nil. So it's trying to call content on something which is nil, which is this thing. And that would only be nil if this selector didn't find anything. Let's go to that page. It's math for bit 7071 or 1071. Okay, 1071. Math for bit. No description available at this time. If I go to the actual page, okay, it's empty. So that makes sense. It makes sense why the thing crashed. So I can just extract out the description by testing to see if that thing exists. I'll use a ternary here. So if this thing is truthy, meaning in our case here, anything that isn't nil will resolve to false. So if it did find something, go get the course description div's content. And if it didn't find anything, just say none. And then here I can output the course description, and that should solve that problem of there potentially being no description for some of our courses. And there you are. And there's full stack web development, the course that you are in right now. There's all the other courses and their titles and their course codes. And we've built a simple little web scraper. So just to recap, we started by opening up the root page, and this is usually how web scraper works. You want to find a root page that will allow you to sort of branch out. So in our case, the root page was the course description page for the bit program that had all of the courses on it. That was this page right here. And then we're going to grab each course code and course name and then navigate further into a separate page to grab the course descriptions. And so we grab the HTML that's at that URL, reading it in from the open command. We hand that HTML off to Nokogiri, makes us a Nokogiri document. We can then use that Nokogiri document to do a CSS selector. And by inspecting the page, we saw that courses were identified in this way, that we can find all courses by using this particular CSS selector. And once we had found them all, well, then we could loop over that collection of elements. And for each element, we could extract out its span contents and the link content to find the course code and the course name. That was because each one of these divs here had a span and a link inside of it. There's the span and there's the link. And then further to that, we grabbed the URL, did a little bit of fix-up in that we made it into a fully complete URL, not a relative path. We replaced a hash mark, so it wasn't going to just navigate to within the same page. It was going to navigate to a completely new page. And it just so happened that the URL structure worked out really nicely, that if we change the hash mark to a slash, it just so happened that that led to the page for that we wanted to pull the description from. So that was just a bit of a happy result there. And then we actually visited that page. So we made another HTTP request for each of the pages, read in the HTML that was there, made a whole new Nokogiri document based on that, did a little bit more research to find out what our CSS selector would look like to target just the course description on the course page, pulled that out, little bit of a fix for courses that did not have descriptions, and then we could print out the information that we required, and we saw that this is the output. And again, if this was a seed script, at this point in the script, we could be populating a courses table with the course code and the course name and the course description. Okay, and so that's all I wanted to demo for today, an example of doing some web scraping where we were sort of spidering out from one main page out to a bunch of separate pages, and also an example of consuming a RESTful API where also we started with one main thing, which was visiting a number of people endpoint URLs, and then we spidered out to their various homeworlds and the films that those people were part of. Okay, thank you for listening to this screencast, and I will talk to you soon. Bye-bye.